Welcome to a demonstration of a 1-bit memory circuit. What this does is it can save the value 0 or 1 and remember it as long as the power is turned on. Here it goes. I turn on the power and the right diode turns on. This tells us that we are now ready to save a bit of value 1 or 0. To set the value to 1, I use the right cable here, which is now not touching anything. As you can see, it's just hanging in the air. And if I connect that to the minus, which is the lowest row of connectors, you can see that it changed state immediately. And now you can see the connector is not touching the minus. We have now saved the value of 1 bit, and this will just stay there for as long as we don't change anything. If I want to go back to the original value of 0, I use the other connector and I connect that with 0, as you can see here, with minus. And when I did it, it changed immediately back to the original state. And that's it. That's how it works. So how does this work? I have a circuit drawing or diagram here that is pretty much similar to the actual circuit. And to give an overview, we have the plus 5 volts going in here, and that we get from the battery pack here, and this is the red wire. And the top row, which is kind of like isolated, this isolated row in the top, these are all connected to each other sideways. So all of the holes at the top row are connected to each other. Similarly, at the bottom row, they are all connected to each other also. So all of these are connected to each other. It's different in the middle. In the middle that we have these columns of 5 holes each, and these columns are connected in the back with each other. So that's how it works. Yes. You can also see, if you look at the back of this board, you can see the lines here which show how the connections are in the back. Okay. Yes. Okay, so back to the diagram. I have a pretty big red box here, and this I wrote just to make it easier for you to distinguish which is important of this diagram. And everything that's going on inside of this is not so important, because we have 2 transistors and 4 resistors here, and also 2 resistors there. And all of these components are just included to make this a better circuit, because we do not want to have a high current going into the microchip, which is this one here. So this chip should be just handling really low currents. Okay, and if you Google this number, you can see the exact drawing of this microchip. But we can see that it has a specific shape here, this one. And this is a NAND gate, actually. So before I explain how this works, we have to look at how NAND gates work and what they are actually. So now we see a schematic drawing of a NAND gate made of 2 transistors. And if you want to learn more about the transistor, you can just Google it, and there are plenty of explanation on the web. Okay, so this is made out of 2 transistors in series. That means that we have 2 inputs, A and B, and if they are both low, that means that there's no current going into either of these. Then this will have a high, this input will be high, because then the current will flow through here and then out to this out point here. But if we turn both of them on, then you can see that this one will open up and this one will open up, so the current will flow directly through these two and down to ground. So in that case this will be a low input. And if A is has a high input but not B, then this will be high again, because it requires that both of them are open to make this one low. And to just get an overview of this, we have a truth table for an AND gate, which just says the same as I just said before. A and B are 0, the output is 1. A is 0, B is 1, the output is 1. A is 1 and B is 0, the output is 1. And if A and B are 1, then the output is 0. So this is what we're going to use. Okay, welcome back to this circuit explanation. Now we have all the ingredients, so to speak, and I can now show you how this microchip is actually working. So if we go to the diagram, you can see that the microchip contains two NAND gates, which work just as explained in the NAND gate video. The microchip is actually just a collection of NAND gates, actually, that's all. We have 7 pins on each side. This one, the top left corner, is the power in, and this, the bottom right corner, is the power out, so the ground. And in between there are 4 NAND gates. And I only use 2 of them. I actually used this one and this one. The other 2 are not used at all. Okay, so back to the diagram. The connection to the first NAND gate, you can see there, it comes from plus all the way here through this resistor and down to this first input. And I'll show you where this is on the actual board. So the power to the first gate is coming from plus here, all the way on the top here, to this resistor. Goes, just zoom a little bit in here, goes into this second hole there. And remember, this column is connected in the back, so all these 5 holes are connected to each other. Goes with this wire over to the second leg here, and that's why this second leg here has a connection to the plus. Okay, and similarly with the other input from the drawing, this input here, it also comes from plus through the resistor, and I'll show it to you here. Okay, from the battery pack here and through the plus line, so to speak, through this resistor and into this column of 5 holes which are connected again, and through this blue wire over to this leg here, which is one of the 2 inputs to that gate. And again, I can show you the gate. If you remember how it looks like this. You can see the inputs are 1 and 2 for that gate, and the third is the output. Okay, so now we covered the 2 inputs, and now we need the 2 other inputs. Where are they gonna come from? And actually, the NAND gates are connected to each other, just like in the drawing. So this third pin here, that's the output of this gate, and that goes into the number 2 pin here. And remember, the first pin is the power pin, so it doesn't count with the gate. So number 2 pin and the gate is connected here, And number 3 pin in the gate is connected to the input of the other gate. So they're connected on a crossing each other. Okay, and these outputs from the gates are connected through this resistor into this transistor here, and whenever this is high, this is gonna conduct current, and this LED will light up. So that's what happens. And now I can see the minus has just escaped this, so I'll put it back in so we can get some light on this one. Yes, like that. The other output here is also connected through a resistor until the second transistor here, and when this output gets high, this transistor opens up and permits this LED to light up just as it does right now. So in this state, as we see now, this gate here is open. And this concludes this explanation of a 1-bit memory circuit. I hope it inspires, and maybe you can do some further work on this subject. Thank you very much.